Hi everybody, this is Miss Lorenz. I'm going to talk through 1.8. This is in the 8th grade math book. It's about using powers of 10 to estimate numbers and to estimate quantities. And you have quite a few problems to do here where we're looking at either really big or really small numbers. And so this should be a video, a mini lesson video for both 1.8 and 1.9, Understanding Scientific Notation. So we're going to use this video for both. So what I'd like you to have is have this science book or math book out, and you need to have it open to page 56 and 57 all the way through 61. And then your math notebook. And we're going to start with your math notebook because I want you to write down some things. To start with, I want you to write down this idea about why we use scientific notation. So scientific notation using the powers of 10 is essentially used when we're talking about really big and really small numbers. Really big or really small numbers. So when we're talking about microscopic particles, for example, those are really small. The size of a virus, that's really small. We're going to want to use scientific notation to write the size of those tiny little objects. Things that are really big, like distances in the solar system, those are so big, or like how much money Jeff Bezos has, for example. Those are really big. And instead of writing all the zeros and counting all the zeros to make sure that you have it correct, it makes more sense to use what we call scientific notation. So here are some basics. And I would expect you guys to write all of this down in your math notebook. This is all going to help you as you complete 1.8 and 1.9 both. All right, so even though I just said we use this for really big and really small numbers, I'm going to give you an example where it's not really big and really small, just for the purposes of an example. So if we look at the number 215, we could write that in scientific notation by putting a decimal right here between the 2 and the 1 digit, and we are looking at 2 and 1500ths times 10 to the second, right? Because if you put a decimal here, I'll do it here, between the 2 and the 1, and then you multiply by 10 two times, 1, 2, or multiplying by 100, we get 215. But that's writing the number 215 in scientific notation. So this is what we mean by scientific notation. Here's one where it's really small, so I'm using the same digits as before, but I'm putting it in a decimal form, and I'm adding a couple zeros, so it actually shows a pretty small amount, right? So we're in the 215, tens, hundreds, thousands, 10,000s, 100,000ths place. So again, I want to put the decimal between the 2 and the 1. I always want to put that decimal between the first two significant digits. And then this time, look what happens. If I put the decimal between the 1 and the 2 again, and I want to show this number in scientific notation, I'm going to have to move the decimal 1, 2, 3 places, fill in those places with a 0, and so since I moved it 3 places to the left, I essentially divided by 10 3 times. So here I'm showing I'm multiplying by 10 2 times. And here I'm showing I'm dividing, because notice I moved the decimal to the left, by 10 3 times. And so we love using the powers of 10 in scientific notation because we all know our base 10 system since you started making sense of numbers and money. So it makes a lot of sense for us to just move the decimal to the left and the right. Some pieces that I really want you to make sure you have down are these positive powers of 10. And these, of course, are not all of them. They continue, but you should know that 10 to the first is 10. 10 squared is 100. 10 to the third power is 1,000, and 10 to the fourth power is 10,000. You probably already know these, but we consider them the positive powers of 10. Now that we've looked at exponent rules, you can look at the negative powers of 10. So 10 to the negative 1, that's going to be a tenth. And if we write that in its decimal form, again, we look at it here, and we know that we read that correctly as a tenth. 10 to the negative 2 would be 1 over 100, or 1/100th. 1/100th. 10 to the negative 3 is 1,000th, and 10 to the negative 4 is 1/10,000th. And it's important that you also know, and of course that continues, the negative powers of 10. And so just to sum up, let's go to this. So essentially what we're looking at is this. If we take 10 to some number, could be 6, it could be 26, you're going to just multiply by 10 that number of times. So if your x is 6, you're going to multiply by 10 6 times. If your x is 26, you're going to multiply by 10 26 times. And the same goes if you have a negative exponent, except that, of course, we're looking at 1/10 multiplied by a tenth, multiplied by a tenth, that x number of times. All right, so let's do one of the try-its together before you get to work on some of the practice problems on your own. All right, I'm on the bottom of page 61. This is the end of 1.9. So if you got through 1.8, both sections go together pretty nicely. So here you're asked to write these numbers in standard form, which is a little ridiculous when I look at the size of the exponent, but it's okay. So I'm going to write this one up here. We have 9 and 225 thousandths, and I'm multiplying by 10 to the 18th, and that is a positive 18. So that means I'm multiplying by 10 18 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And of course, I am going to fill in all of my zeros. See why I said it was a little bit ridiculous? Now I'm going to put my commas in, but I'm going to make them giant commas so you can actually see where my commas go. And so let's see, that'd be millions, billions, trillions, quadrillions, quintillions. This would be 9 quintillion, 225 quadrillion in standard form. See how ridiculously long that is? You wouldn't want to have to write that number out. That's why we use scientific notation. So we can just put a decimal between the first 2 digits. You would oftentimes even see this as 9.2 times 10 to the 18th. All right, let's do the next one. This is 6 3/10 times 10 to the negative 8. So it's not quite as bad here. This time the exponent is negative. So that means I'm going to divide by 10 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Put my decimal in, fill in my zeros, and we have this really tiny 1, 2, 3, 4, 5, 6, 7. Really tiny decimal, tenths, hundredths, thousandths, 10,000, tenths, hundredths, thousandths, tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths, 100 millionths, billions, 63 billionths. Again, ridiculous. You wouldn't want to write all that down, count the zeros like I was just doing to make sure that you had the correct number. You would rather just put your decimal between the 6 and the 3, and then count how many places you have and multiply by 10 or divide by 10 to that place. Or in other words, multiply by the negative exponent. Okay, I hope that helps everybody. I'll talk to you soon. Thanks for listening.